So the ratio of Renee's age to her aunt's age is 3 to 11. In 4 years, the sum of their ages will be 78. How old is Renee's aunt now? Okay, so we're talking about a couple of different things. We have Renee's age. I'm gonna use R for that. I think it's rather than X and Y. If you can use meaningful letters, that way it'll be easier to remember what they are in the end. So that's Renee's age, and then we have the aunt's age. And that's going to be capital A. So we have Renee's age, we have the aunt's age. Okay, so this is another one with 2 letters, so we're thinking we need 2 equations. Here comes the first one. The ratio, remember that means fraction. Renee's age to her aunt's age is 3 to 11. So Renee's age over her aunt's age is 3 to 11. There's the first equation. And then the second is right here. In 4 years, the sum of their ages will be 78. Sum means the adding up, right? So in 4 years, the sum of their ages will be 78. Now that 4 years part is a little bit tricky. So I'm going to come over here and say, well, Renee's age in 4 years. Renee's age in 4 years, if R is Renee's age now, then in 4 years, Renee's age is going to be R plus 4. And we got to find the aunt's age in 4 years. And so that's going to be the aunt plus 4. Like that. Okay. So now we can come back over to this formula. We can say the sum of their ages in 4 years. So that would be the R plus 4 plus the A plus 4, right? That's their ages in 4 years added up equals 78. So there's our second equation. That one's a little tricky, right? In 4 years, so R plus 4 and A plus 4, their ages will add up to be 78. So we have our 2 equations. We've got that one, and we've got, a little bit funny. Get this one. There we go. So we got our 2 equations. And so remember what we do when we have 2 equations. Step 1, get one letter alone. Having a little bit of a writing problem. Get one letter alone in one equation. Doesn't matter which equation, doesn't matter which letter. Just get one letter alone in one equation. So I'm just going to grab the first one again, like I did last time. And I'm going to go diagonal, diagonal. Cross multiply, bring that down. So that'll be 11 times R is 3 times A. That's what we do with equal fractions, right? We go diagonal, diagonal, cross multiply. Okay, and then I want to move it over here. I want to solve, I want to get one of the letters alone, right? So you know what we're going to do? We're going to divide by 11. And so R will be 3/11 A. R is equal to 3/11 A. So we've got R alone. So now step number 2, plug that letter into the other equation. Plug that letter into the other equation. So I'm going to grab the other equation right here. Bring it on down. So we have R plus 4 plus A plus 4 is 78. And I'm going to need to plug in this R right here. 4R. So what do we get there? We get 3/11 plus 4 plus A plus 4 is 78. Am I losing you? Are you tracking with me so far? Is this making good sense? So this is what we do when we have 2 letters and 2 equations. Again, the game plan is always to get 1 letter alone in one equation. So I just took this one, cross multiplied, divided by 11, got R alone, and then plug that into the other equation. What we always do with 2 letters, 2 equations. Get 1 letter alone in one equation, plug that into the other equation. So now you get an equation that only has 1 letter. See how this only has 1 letter, just A? It's a difficult equation, but it's only got 1 letter. Whoop, just A. See that? There's no more R. So now we can solve that equation, but it's easier said than done. How do we do it? Well, it is a little tricky. We're going to need to, let's add the 4 and the 4, so that's 8. That's not too bad. And then how are we going to add the 3/11 and this is really a 1A, huh? So we need to add those together. How do we add 3/11 and 1A? And then of course we also added these other 2.
I'm guessing you would get the common denominator, so you would multiply 1A as 11/11.
Yeah, good job, exactly. Yeah, let me do it over here on the side. That's exactly it. Over here, 3/11 plus 1A. Yeah, exactly. It's 3/11 plus 11/11, right? So what's that? 14/11. Everybody good with that? That's exactly right. Or yeah. Maybe I'll just do it right here where we have a little more room. 14/11. There we go. Yeah, exactly. Yeah, to add 3/11 and 1A, you got to make that 11/11. And then that makes 14/11. Yeah, so bring that back. 14/11. Yeah, so that's how we add the like terms there. Exactly right. So that's a little tricky. We're dealing with fractions and a lot of what we've studied this semester. And now subtract 8. You know what to do here to solve for A. This cancels. So we get 14/11 is, what's that, 70? And now remember the step we took on that earlier problem? We're going to try to get A alone. What can we do in one fell swoop to get rid of that whole 14/11?
Take the reciprocal.
Yeah, 11/14, huh? On both sides. Cancel, 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 right? So you multiply both sides by the reciprocal. And there we go. Just use your calculator now. Just take, it's going to be 70 times 11 divided by 14 on your calculator. That'll be 55. And we're done. That's what they wanted, because and what's nice is we used meaningful letter A, so we know that's the aunt, and that's what they said right here. How old is Renee's aunt now? Well, A is the aunt's age, of course. So the aunt is 55, and we're done with the problem. So there's the whole problem. If you want to screenshot or picture anything, questions I can answer on that one. So again, it was 2 equations with 2 letters. And so we always handle that by getting 1 letter alone in one equation, plug that into the other equation, and then go through the steps to solve. All right. You're good.